So far in the first lecture, we went over some grading policy, and then second part, we went through summary 5, so thanks for asking that question. I'm glad we did it. And then now let's just look at chapter 13. Okay, so chapter 13 is called Penalties. Up to this point, what we've really done is summarize all the great things that we get from conventional energy, right? We get transportation, we get communication, we get all these fantastic materials that we use. So what's the catch? What's the downside? So table 1.1 looks at several primary energy sources. I'll just read through them. I'm not showing that right now, but oil, natural gas, coal, nuclear, biomass, hydro, wind power, tidal barrages, geothermal, and solar. So the first 4, oil, gas, coal, and nuclear, are all the conventionals that we've covered. So the problem with oil, global warming, acid rain, oil spills, oil rig accidents. There's a movie coming out about that. Land being spoiled, so that's the concern right now in Standing Rock of what happens if that pipeline breaks under the Missouri River. Natural gas, global warming caused by CO2, combustion, pipe leakage, just direct methane in the atmosphere, explosions, obviously there's danger, gas rig accidents. Coal, again, you've got global warming from CO2, combustion, methane leakage from mine, acid rain, environmental open cast mining, so all the tailings end up in the rivers, etc. Land subsidence due to deep mining, soil heaps, groundwater pollution, mining accidents, of course, and then health effects for miners. Nuclear, you got radioactivity, misuse of fissile materials. Go check out thorium. You should definitely check out thorium when you get a chance. Nuclear proliferation we discussed, land pollution, health effects, etc. Biomass. So all, and when someone says, "What's the best energy?" You can just turn around and say, "Well, what's the worst?" And then you can say, just argue ad infinitum. Well, sorry, pick your poison, right? So, biomass, effect on landscape, habitats, biodiversity, groundwater pollution from fertilizers, use of scarce water, competition with food, right, for biomass in case of ethanol. Hydro, construction of dams, displacement of people, effect on rivers, visual intrusion, accidents, downstream effects of agriculture, methane emissions from submerged biomass, because you're cooking all that stuff that you just drowned. Wind power, visual intrusion, noise, bird and bat strikes, TV reception, aircraft radar. Tidal barrages, so this is where you'd have energy storage, offshore. Destruction of wildlife habitats, reduced dispersal of effluents. So you just end up with stuff kind of, low tide, that low tide smell. Geothermal, release of polluting gases such as SO2, H2S. That's the stuff you smell when you go to Yellowstone. Groundwater pollution by chemicals. You might have some heavy metals, and you might induce seismic effects in the same way that fracking might do that as well. Solar, occupation of large land areas, use of toxic materials such as cadmium in manufacturing, and visual intrusion. So again, there's no perfect energy technology, right? They all have their downsides. I do know on the exam's going to want to know how these things are classified. So the book says, by the scale, how big they are, by the source, where it's coming from, and then the public concern, who's really worrying about this and why. So scale, global, regional, community, workplace, household. We just talked about the sources, the 8 or 9. Public concern, and gosh, I won't go into it, but table 13.2 talks about that. Health effects, life expectancy, food production, water pollution, land pollution, visual, there's all kinds of public concern. Okay. So this graph shows source and scale. The source is oil, and the scale is just showing the different sizes. So each of those little circles, Large oil spills greater than 7, so it had to be greater than 7 tons. You know about what 7 tons is like. It's probably like the, volume of a large walk-in closet. Up to greater than 20,000 tons. And you can see there, the small, or the light pink are more recent. The darker ones, I'm sorry, the light pink are longer ago. The darker are more recent. The good news is, I suppose, that there are fewer dark ones than there are light ones. And you might say, well, that's a good thing. We're just getting safer. There's a lot of GIS that goes into this, mapping shorelines and, and safety and autopilots on ships and just better engineering, keeping the stuff from spilling. And you can also see, from both sides, why would an oil company want to spill its commodities? So it's a lose-lose, right, when these things happen. All right. These graphs, if you ever do sort of carbon accounting, or if you're a sustainability officer, these graphs become quite pertinent. So it just shows, it's not all that easy to digest it first. But let's just look at this. So abatement costs. Let's just say your whole goal is to reduce the amount of carbon emissions. You can say, that's kind of my bottom line goal, is to reduce my amount of carbon emissions. So there's a lot of different ways I can do this. So the fact that some of these are below the line and some of these are above the line is not is inconsequential. That's just where they had room to type it. And I was going to dive right in here, but this seems kind of confusing. So here's waste recycling, and here's electricity from landfill gas. The problem is, I think they are both pointing to the same little chunk. All right, so let's look at the costs here. So this is actually showing that if you switch from incandescents to LEDs, it's actually going to save you money. It's going to cost you negative money. That's why all these numbers are below. Same thing with the insulation. Yeah, you're going to buy the insulation up front, but it's going to save you money, and it's going to save CO2. Now, if we come out a little further here, well, the coal, if you're going to take the coal and go to combined cycle, it's going to save CO2. It's going to save a lot more CO2, but it's also going to cost you money as well. So that's thinking back to that Italian coal paper summary 2, I think it was. So these things will save you money and save CO2. Not a whole heck of a lot. It's something. I mean, you'll notice that all of these numbers on the horizontal axis, they're all positive. So making your motor more efficient, it's going to save you money and save you CO2, because you're going to get more bang for your buck out of your car. Go to a hybrid where you're not sitting at the traffic sign idling, for example. You've got a hybrid engine in there. Waste recycling, and I don't know if I mentioned this very much, but I haven't paid for the landfill in Missoula in 6 years. I've found ways to take all of my waste products and recycle them. And I've had some colleagues looking into, say, doing biogas down at the wastewater treatment plant, like, hey, let's turn that methane into energy, et cetera, et cetera. And then you kind of get in the gray zone. Small hydro, well, gosh, it's small, so you're not going to get a whole heck of a lot out of it. But yeah, you're not going to be burning CO2 as a result. Reduce slash and burn. I think this would be a great policy. There's a lot of this in the news recently about putting loggers, foresters back into the forest to reduce this overburden. Take that and actually turn it into energy, rather than sending that smoke and CO2 up just as a waste product.
Big burn piles that they do.
Yeah. So the point would be, hey, let's take that burn pile and either turn it into fertilizer, turn it into mulch, turn it into wood chips, something other than a big smoky mess.
Yeah, because that's usually, it is just big giant
Yeah,
pile.
yeah. So, and that's where you get into the policy, so if
That could almost be like a business, because on our property, my dad has 4.5 acres and we'll do burn piles and stuff. But
Yeah.
if you just go through, clean it up, and then somebody even pays you to take it and then
Yeah.
make money off it.
Yeah, and it's interesting you say that, because right here, we're kind of in the gray zone. And the same thing is, should I plant a garden or not? Well, I'm going to plant my garden, but it's only going to grow me a few $100 worth of food, and what's my time worth? Should I really bother planting the garden or not? It's right in that little tipping point of the teeter-totter, so, yeah. So these well, and I guess the other way to look at it is if I were to take the entire thing and flip it, which is greater? So I'm looking at it just right off the top of my head here, and it looks like this total area is larger than this total area. But coal retrofit. The other thing to note is these numbers change all the time. We were just specking out prices for solar PV. Back in the 70s, 80s, it was $10 to $20 a watt for solar PV. Earlier this year, we were looking at the best prices. It was something like 67 cents a watt. We just spec'd out some panels for a 2 megawatt array last week. 41 cents a watt.
Wow.
95% reduction.
Yeah.
Wow.
Yeah. So what you'll see is this solar PV could shift from a sort of a skinny short to something that actually is, where would you put it? It would cost less, so it would sort of come to the left, and it would actually spread out. Yeah, it would cost less and spread out. So it would slowly shift, and at some point, heck, maybe it flips, and it's right here, and it actually costs you less to do solar. And there are places right now, in fact, some of these island nations where solar is $1.25 a kilowatt hour, it's going to be sitting right over here. Win-win. Okay, so that's how to look at this graph. Yeah, it's good. It's
Cool.
it's a good. You look at it first, I don't know, that's weird. Why is it doing that? But so and again, just thinking back to our entropy example, where entropy it's a scalar, just like temperature. So there's an entropy acceleration every point on the Earth and the universe. This is going to be different depending. So University of Montana's numbers might look different from Alaska's or Florida's, depending on what technologies are there. So, okay. All right. So this is just showing coal, oil processing. So this will be the last slide we look at here today. So stages of the fuel chain for electricity. So really the whole point of mining coal in general is to make electricity. So as you're mining, there's dust coming off. In the processing, there's NOx coming off. There's some CH4. There are some emissions to the groundwater, assuming there is groundwater. There are air pollutants as it's shipped. We see the coal trains coming through all the time. The numbers aren't there, but of course this is happening. And then at the plant, you're coming out with one kilowatt hour of electricity. So that's the stages in the fuel chain for electricity from a coal-fired power plant, showing impacts. And then B is various stages in 2 passenger transport fuel chains. So in this case, you've got coal on the top, you've got oil on the bottom. Yeah, so what they're comparing is, let's just say you wanted to run an electric trolley versus run your car. And this is really all this is doing, because at the end, the whole point is to go that 1 passenger mile. And this is very similar to my paper, where the whole point was just to get to the movies, or wherever you're trying to go. You're trying to get that one, or go meet with your friend or whatever. The whole point, the goal was to go that 1 mile. To do so, if you're going to use electricity, and it's the same thing. I've got a 1972 VW Bug sitting back here that an aircraft pilot from Alaska gave me, and I'm talking with a buddy. He's like, "Oh, you got a coal-fired power car?" Well, not if I can just take that little car and plug it into the wind turbine back there. That wind turbine was ripping on Thanksgiving. I went back there and the thing was just cranking away. But typically, with the majority of our electricity coming from coal, these are the steps in order to get the electricity into the car so you can go that one kilometer, versus, hey, let's get the oil or the gas out of the ground and go that 1 passenger mile. Sean Hannity was saying that he's in favor of natural gas powered cars now. Did you guys hear that at all? It's kind of weird. And there have been, in fact, the university still has a natural gas station. I don't think we have any natural gas vehicles, but there was one here in town a few years ago. But anyway, the point is, these are the things we want. I mean, these are the things we need, and this is sort of what's on the front end to pay for it. Okay, so on Thursday, we'll just look at other costs in various realms. Take a little bit of look at climate change. I know you guys are probably already experts in that. Some of the sources. Yeah, so shoot me an email if you need help with that summary. That last summary is kind of a little bit gnarly, but I know we spent some good time looking at it. Yeah, and then next week, chapter 14 are just remedies, kind of what we can expect to see in the future of energy. So that's it.
Right.
Thanks, everybody.
Have a good week.
Yeah, thanks too. See you Thursday.
Have a good day.
All right, see you, Matt. Thanks.